I have an important announcement to make. Game-changing discovery. Game-changing. So basically, I was looking to buy the two-part epoxy that's high heat for masking traces and also for gluing down replacement pads or replacement traces. You can use it for gluing down and for masking. It's high heat epoxy. I was looking for that electrical epoxy and I stumbled across silver epoxy that's electrically conductive. And that blew my mind. As soon as I saw that, I was like, electrically conductive epoxy? Why would someone want that? Oh! 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 Oh my gosh! My mind was blown. And I can never turn back now. Provided that it's very electrically conductive, and the good stuff is, there's some knockoff brands that are pretty much resistors. It's like, oh, let's put some silver flakes in normal plastic, and let's hope that doesn't have enough resistance. Yeah, right. But there's very expensive silver epoxy that has 0.00001 ohms of resistance per centimeter of a trace. Now here's why that's so brilliant. If you can get a fine enough output nozzle to put very fine traces, you can create very tiny traces with a lot of control with your hand. You just stick it on and use it like a pen, and you just brush it on. And they even have silver pens where you just draw on the traces. Some of them have the ball style, just like a ball pen, like a normal pen, where the ink comes out and a little ball guides the ink. They're like, wow, my camera doesn't want to. That. So they have epoxy silver pens that work like that with the ball, and you just draw it on. Gold would be too expensive, I think, yes. But if they could create that, maybe a gold pen. But I think silver is very much good enough for electrical work. It absolutely is, and people have tested it. I read in the comments. I've been watching videos about it now. I read in the comments this has been around since 2006. It's just not used. Nobody knows about it. I never even heard of this, and I've been watching electrical videos, hundreds and hundreds of them, repairing electronics videos, making your own PCB videos, all of that. I've never even heard mention of silver epoxy at all. And that's a huge mistake. Okay, so imagine if this pen, rather than being ink, had silver epoxy in it. And I just draw my traces like this, and then stick the finished circuit board under a heat lamp, and then it's done. And it's more strong than even a circuit board would be, because it's silver epoxy. Epoxy is super strong. It's very strong. Okay, so this is what I'd do. I would put all my components on my board, right? And we're talking, they could be tiny. I'll put all the components down wherever I want them. So we're talking SMD. I can use SMD so easily now because, okay, so you put your tiny little QFP microcontroller. Tiny. Tiny, tiny. Something that you can barely solder to. And if you could, you're only doing that because you bought a printed circuit board that already created perfect traces and pads, and you just perfectly align it with tweezers, and then you drag solder it, and it's really hard to do even then. But you don't need any of that. You can just stick this on a piece of paper, whatever you want. You could stick it on a little flat piece of plastic, whatever you want. You could stick it on anything. If you're building a robot, you could stick it directly onto the frame of the robot. Whatever you want to do. You don't even need a circuit board. You stick it onto whatever, right? And then, oh my gosh, I just thought of something else, but let's get back to that later. Well, I was thinking you could stick it on a wire, on the insulation of a wire. You could stick a surface mount component. That would be pretty sick. And then you just cut a little hole in the wire, you drill a hole, you squeeze the silver epoxy into that hole till it touches the wire, and then you you squeeze it up and along the insulation and over to the surface mount component, which is going to be then glued to that wire, and then you can fork off from that. There's a lot of stuff you can do, very tiny level stuff, if you don't have to deal with soldering. You couldn't do what I just described. Drill a hole through insulation, squeeze in some silver epoxy, keep squeezing it, and then start traveling along the insulation, now creating a conductive path parallel to that insulation, and then you could fork off of that with components glued right onto the insulation. There's crazy stuff you can do that doesn't exist. It's not possible without this type of technology. So you can get it in a syringe type or a roller pen. Roller pen would be great for just rolling a trace onto a flat surface. Syringe type would be great for if you wanted to inject the silver into, like I just said, like if you drilled a hole down to a conductor, you want to eject it and fill it with that silver and build it up and out and then over, then you'd want to have a syringe. You could actually use a medical syringe to squeeze it. Okay, so you set out all your components on a PCB, right? Not in Eagle, not in CAD, whatever. I mean, sure, you can design it that way if you wanted to, or just design it on paper, just drawing it, or design it in Photoshop. That's what I do. I'm talking about you have your circuit designed, but you don't have to do board layout and stuff per se. I mean, you still could. But the point is, if you didn't want to mess with all that stuff and work with CAD files and all this stuff, I mean, some people do that, whatever. But I'm saying just for prototyping work, or, you know, small runs of stuff, we're not talking about mass manufacturing, overhauling that industry. I'm talking about DIYers doing repairs and doing prototyping work, or building a robot one-off where you're not producing thousands of the same board. We're talking about just prototyping work, we'll say. Okay, so you lay all your pieces out on Vero board or whatever, and then they're not glued or anything. The surface mount components are all just laid out tiny, and then you just draw the lines between them all. You just draw it, connecting them all up, and then you put it under a heat lamp for a half hour to an hour, and then it's done. And all the pieces were glued by the silver epoxy, because the silver epoxy ended at and touched and wrapped around all the pieces. And so it's all connected. It all works now. It's that easy. This is game changing. Now, here's another thing I thought of. Okay, the big question that's difficult is how would you connect like a BGA processor? How would you connect to that in a dead bug style? When you don't have a printed circuit board to start out with, you're just creating a circuit by hand from scratch as a DIYer without wanting to bother with PCBs and working with Eagle and doing all this stuff. You want to do it by hand. Okay, this is how it's been done. You use 30 gauge Kynar wire. You strip off the end, and then you stick it on each of the little pads of a BGA processor that's placed upside down with the pads sticking upward. Okay, and you stick the wire on, and you tediously, under a microscope, solder it onto the pad coming off the processor. And now you've got a wire connected to that pad, and now you can send that wire over to wherever it needs to be, to the next pad or trace or whatever, or to the component it needs to connect to, what have you. Same thing with microcontrollers. When you're doing prototyping work without doing a PCB, you need to solder a very fine, so 30 gauge Kynar wire to each output, and then wire that over to wherever you need it to go in your circuit. With this though, okay, we're dealing with BGA, so the pads are facing upward, like a system on a chip from a cell phone. The pads are all facing upward. You would do this. Starting from the outermost pads, you would draw with silver conductive ink from the pad. You'd stick the pen there, you draw off, and then down the chip, and then down the board to where you want it to go. And then that's done. And you do that on all of them. Now, for the next row in, and you're still wanting to go this way, well, what do you do now? It's got to go between the lines you already drew. That's not possible. Okay, so you're stuck, right? You'd have to go around it, right? Wrong. Here's where the magic happens. After that first layer, you put down solder mask over that whole first layer. A thin mask that is not electrically conductive, protecting the first layer that's all going this way. You brush that all in solder mask, let that cure. High heat epoxy solder mask. So you put that down under a heat lamp, it's heat activated, let it cure. So now all those traces going that way, which all went to their destinations, are completely protected. Now you draw from the next row going right across and above those traces. You draw your next set. Not even worrying about those traces, they're solder masked already. You draw right over it. And so you can actually create like a cable, a wire cable, go and then fork out everywhere into the circuit with the lines being drawn over one another in thin layers, because this thin layer you drew and then solder mask, you can draw right over it the next layer. And that also is totally EMI compliant and everything, because having wires run really close to each other, well, maybe actually signal wires close to each other might cause conductivity issues. So, I mean, well, you could solve that. Here's another way you could solve that. Take some really good electrical tape and just tape down over it in addition to create actual thickness, and then run your next group over it. That would be fine too. Or you can put down the high heat epoxy and then put down a sheet of rubber over that, you know, electrical tape to glue down the electrical tape even better. I don't know. I personally would use adhesive transfer tape with nitrile glove rubber, which I make all the time. It looks like this. I would just tape this down and then draw over that. So that's how I could separate the traces, with a nice thick layer of protection that actually separates the electrical signals by a little more distance. But actually, I don't think the distance matters that much, because here's why. If you look at the traces on any PCB, they're right next to each other. Like if you look at your motherboard inside a computer under a microscope, like all the traces are drawn with very little distance when you're coming off a processor. So I don't think it actually interferes with anything to have them really close to each other. So I think as long as you build up, you know, maybe a nice thick layer of that epoxy insulation, or heck, even just put the high heat epoxy and then put, or you could use Kapton tape, possibly. Yeah, maybe Kapton tape. I think that's not electrically conductive. But the point is, between each layer, so you could also put maybe lacquer, paint polished lacquer, which could maybe be built a little thicker, and then put another layer of the high heat epoxy. I don't know, there's different ways you could do it, but the point is you could build up a layer over the first line of traces and then send the next line of traces over it. And so you can fit a lot of traces in a very small area. Even like 1 millimeter thick, you could have thousands of traces over a 1 millimeter thick area, because you can put them in layers, paper thin. So you can just send as much wire as you want in as small as area as you want, and then fork them all out like a tree branch into all the components later. So that it just gives unlimited capabilities that even etched PCBs cannot do. If you look at the components spread out on an etched PCB motherboard, motherboards are, you know, this big, ATX motherboards, and all the components are way spread out. You could crush everything together with SMD parts and then make it really small, and then by hand be able to connect everything. If you're able to have traces overlap one another, you don't have to worry about them not overlapping. That's a huge advantage that you can't do with etched boards, unless if it's multi-layer printed circuit boards, which are very expensive. And basically what I'm proposing is a way to hand draw a multi-layer printed circuit board by hand using silver conductive ink, followed by laminate, followed by silver conductive ink, where the laminate prevents electrical connectivity between the two different layers, and you can do very complex boards this way. and it's game changing. So I will be definitely doing this, and I'm thinking now, like, why would I ever want to even bother when using prototyping boards with using wire to connect one part to another? Why use wire? Why hasn't the maker and DIY community seen the power of just drawing the conductive connectors? Drawing it. You don't have to cut and strip and lay down perfectly and use extreme precision to solder a nice joint and then worry about possibly a little bit of solder bridging two joints, and then you got to go over it again, especially when you're doing very tiny fine pitch stuff. Drag soldering techniques can be perfected, blah blah blah, skill can be developed, there are techniques, I get it, using a lot of flux, and I've been learning all about that. But what I'm saying is, it would be way easier just to draw it with ink, conductive ink. I think conductive ink gets a bad rap because most conductive inks are crap, and they're used on like wearable clothing and stuff, and they have a lot of resistivity. So that gets rid of that one problem why people haven't really taken to conductive inks, because of the bad name it created for itself, because a lot of crappy low silver content inks, or crappy inks in general, that have made people turned off to the whole concept. We're talking about high conductivity, great inks. That's the key. You got to buy the expensive stuff, a lot of silver. I imagine you could even make your own. It's probably not hard. You probably just need to buy silver powder and mix it with some kind of epoxy that wouldn't really interfere with that. That's a high heat activated epoxy. You could make your own. Just buy those two things. So I'd be interested in researching that as well to save money, because I think you could just buy a stick of silver a lot cheaper than you could buy epoxy silver. But price aside, I think any price is worth paying, honestly. You know why? Because of the tremendous amount of labor and time it's going to save. I can just set up all my components, draw lines between them, stick a freaking heat lamp on, and I'm done. I can make circuits way faster than having to mess around with cutting the insulation off all the little jumper wires and connecting it all and gently bending the jumper wires with two little pieces of tweezers and trying to shape them and maybe put some hot glue on them or super glue on them to like form them and shape them and have them all stick together just right. And it's like hours and hours of work. I bet I could do it so much faster just drawing it with a pen, and it's over. There's no stripping wires. There's no cutting wires with a side cutter or with a nail clipper. That's very popular. There's no any of that. It's just draw it on and you're done. Now, one of the problems I saw right away is a lot of people are doing it with a syringe. A syringe is not good for accuracy. To really draw accuracy with pen, you need to be able to hold it like this and really go slow and neat. You want your thumb, index finger, and middle finger all part of the accuracy, and you maybe put one finger out. I know about accuracy because I've done a lot of artwork and drawings that are very accurate. And you want to put one finger out so you can feel and maybe rest your palm on the paper as you slide, and those 3 points of contact really help to keep your line perfect. I'm very accurate with my hands. And I can draw at like 2-point font with a pen. Like, I have insane accuracy. And I could use that accuracy with a proper pen that puts out silver conductive ink. And I can do very, very fine work under a microscope this way. And I can make circuits that are perfect very quickly, including circuits on stuff that has been historically seen as not something you can work with as a prototyper. Like a 325 pin BGA chip. Like, what do you do with that? You don't do anything with that. You have to have a printed circuit board, you have to lay it down just right, and use special techniques to even get it to stick to that with a hot air station. And it's very hard, and some people can't even do it with the right tools. With a Heiko special air station, top of the line, thousands of dollars. What I'm talking about is you flip that chip upside down, you can draw the lines, straight up draw the lines to where they need to go when you're doing a PC repair. You just draw them under a microscope. Okay, So my thought was, how do you get the ink to exit, the silver conductive ink to exit through a needle uniformly? I watched a video where a guy took the plunger of the surgical needle and he pressed, and it's not designed for this, and it had the silver ink in it, and he bought it from banggood.com. He squeezed it out, and it blew off in a big bubble, like a spurt of it, and then it got thin, and then another chunk came out. It didn't come out uniform. It didn't come out neat. So what's the problem? He had a hard time pressing the plunger down with a perfect pressure, perfect regulation. And so in order to solve that, I came up with an idea. It would be based on the design of a 3D pen, which you press a button on the tip of the pen, and the pen has motors inside it that turn and feed out the plastic, and it comes out at a set rate, so you can move your hand and have really nice control. So what I'm proposing would be the 3D pen of conductive inks. You would have a button you press with your index finger, and then a little motor mounted on the pen somewhere up here would turn, and it would have a pulley system, and it would pull, and it would depress the plunger of the surgical needles. So it's a surgical needle pen that is motor actuated, and that allows the surgical needle plunger to be depressed at a fixed rate and allow for the silver conductive ink to exit from the tip of the needle at a fixed speed in order to create solder traces, well, not solder traces, silver conductive ink traces on a PCB that are of uniform width and height. So as you drag your hand, everything looks perfect, and it's not blobby and coming out in bunches and looking sloppy. So you can create really nice, neat circuits this way by hand, just drawing the circuits together and actually attaching the components with this silver epoxy. So it's more conductive than normal copper. It's stronger than normal copper. It's instant, it's by hand, and the traces can be very neat. And the traces can overlap one another for multi-layer boards, so you don't have to worry about the traces being next to each other, because after a group of traces start filling an area and you're running out of room to run a trace, you just lay down some epoxy, let it cure, and now you can draw right over your other traces, new traces. So that way you can create multi-layer by hand printed circuit boards. That's insane. That's insane. That's going to open up so many doors for cell phone style tiny computers that you can make by hand. By hand. And that will open up small scale robotics. We're talking robot mice, robot dragonflies, tiny scale stuff with, you know, the 300 pin system on a chips that run laptops and smartphones. You can put a bunch of those in a tiny circuit board by hand and make these yourself. In order to have advanced computer vision, artificial intelligence, pathing algorithms, movement algorithms, everything on these tiny computers, and you can do all this by hand and fit all this in tiny robots. And it's because of this, you don't need to go out and buy these custom boards then. You could just draw it with conductive ink. So that's what I want to do. I want to make a surgical needle with plunger be able to have a motor that presses down the plunger at a fixed rate in order for the ink to come out at a fixed rate. And I can have precise control. I can have it come out very slowly, so I could just move my hand little by little, creating the most perfect trace or the most perfect pad. I don't actually think pads are necessary. So you don't need a pad if you put your component down and then you just draw until you get to the component, and then you just draw onto the component, overlapping the component, and then just color in the component, and it's all just encased in epoxy. I'm picturing like capacitors and resistors. They have a whole conductive side to them, so you could just draw the ink until you get to that, and then just wrap it all around, creating, you know, like what would be the equivalent of a solder bead all around that. You could just create a little pile of it, and then you're done. and then you release the button and it stops putting out the ink, and then you can put it down, press the button again, and then start drawing the next thing, and then release the button, it stops. So it would be a tactile switch operation. There's no squeezing, there's no using your thumb to press, none of that. And so you get at surgical needle precision with the precision of a fixed output rate of the silver conductive epoxy. It would use an Arduino Nano as the board, or Arduino Mini as the board, and then it'd have a tiny little battery, and then it would have a tiny little, I'm thinking stepper motor, but maybe it wouldn't need a stepper motor, maybe just a tiny little DC motor. And then you'd have your little motor controller, and you can solder it all to, or just attach it all to the needle. And then you might want, if you use a DC motor, you might want a little pulley system that would transfer the rotational speed of the motor pulley to a bigger pulley and then to a smaller pulley. So the little turns of the motor would go onto the bigger pulley, which would go slower, and then to a smaller one, so those would be slower. So you can then increase the torque and slow down the speed in order to have the plunger go a little slower. And then you can also control the speed of the spinning motor through PWM. So you might not even need a torque converter or pulley system. You might just be able to slow it down with PWM as long as you pick a motor that's strong enough. But if you picked a really tiny motor to save on weight, you could torque convert it to increase the strength of the output, and then it'd just go slower. But that'd be okay, because I don't think the plunger should be going fast at all anyways. For very fine precision work, you actually would want it to come out very slowly. But what if it's coming out too slow, or you want to speed it up? With a 3D pen, there's a little slider, which I'll show you here. There's a little slider here. Here's the go button, and then here's the slider button, and you can change the speed of the output. So I would copy that. So I admitted right off the bat that this is based on the design of a 3D pen. So yeah, with that, with a little slider you can make for it, you could change the output speed. So if you want to draw your traces like this, you know, faster, you can. If you want to just go so slow, you can do that just by changing how fast the silver conductive epoxy is coming out of that thing. So I definitely am going to order silver conductive epoxy. I'm going to buy the stuff that has the highest rating and specs of the least resistance, so high silver content basically. Really excellent stuff, because I don't want to deal with any crap where you put it on and it's basically a resistor and it overheats your circuit. I want very high silver content, or just very high quality. I want something that has lower resistance than copper and tremendous adhesive strength. And I know it's going to be expensive, but if I'm just buying the ink in a packet and I create my own plunger system as I just described, that'll be a lot cheaper than buying, I'm guessing, a conductive pen, which might not even be refillable, and they just want you to keep buying more pens. I think that's impractical from a financial point of view. But buying the little packet of silver epoxy, I think it's like $13 for a tiny little packet. And how much circuit board work could you do at a very tiny scale with that? You could do all your circuit board work. That thing would last forever, and it's only $13. So it'd be fine if you're working with stuff the size of a cell phone. For a big circuit board, that might get a little expensive, but who cares? The amount of time it's going to save you messing about with jumper wires and stuff would be well worth it. So I'm excited, guys. Also, I'm going to be buying a dental pick to use for scratching away at old traces to remove the laminate in order to solder to it, or in this case silver pen to it, to create a replacement trace or repair a trace or add a new trace, so that I can tap into existing boards, for example. So that's important to be able to scrape away. Also, if you're using oxidized copper traces or pads, sometimes it's good to just scratch at it to remove the oxidation and make it nice and shiny again, and then you have the ability to solder, or in my case, use silver conductive pen to actually send a conductor off of that. So I just feel like using wire is primitive and shouldn't be done unless if you're connecting one board to another board. Then wire is good. But for making traces on a board, I feel like silver conductive pen, you just draw it on. You don't have to worry about stripping wire and stuff that way. That's so much faster. I'm so excited, man. So, well, you can also take this further. Let's say you do want to use a jumper wire, but your soldering skills aren't the best, and you just want to come off a pin from a processor or something. You want to come off of that with your wire and go to some other point. Well, you can solder it on, but you can also stick the wire against it. No, you can squeeze on some silver conductive epoxy, put the wire inside that a little bit, and then put on some more silver conductive epoxy on top, and just basically you're gluing down the wire that way. And that's faster than soldering it and more control. Maybe solder in that case would be better, but maybe not. That's a tough call then. But it's just something to bear in mind. Just all the additional ways, the possibilities of using silver conductive ink instead of traditional solder and soldering iron. I think it's really important just to think about all the ways. Oh! Okay, here's another one, guys. Alright, let's say you got a piece of wire and you want to tee off of it, right? So the normal way you do it, you strip away some insulation in the center of this long piece of wire. Okay, so you'll use like a wire stripper and you'll squeeze and it's going to pull apart, or you'll use a wire stripper like this and you'll just pull it while holding the other side or whatever. And so you pull apart the insulation, exposing some copper wire in the center. Now you strip the other wire that you want to fork off of that wire with, you strip that and you wrap it around. Okay, and now you have a wire wrapped tee. Now normally you would solder that, but I'm proposing, what if instead of that you just coated all that in conductive silver and move on and continue making your other circuits, and then when you're done with everything, you would put it all under a heat lamp and it would just secure all that. I think that would be easier than having to mess with soldering at all. Also, soldering will wick up the wire underneath the insulation and cause thermal stress on the joint. That's why a lot of times people prefer to use joints that are crimp fittings, because soldered joints create a brittle point where the solder ends and the wire starts. But with with electrically conductive silver joints, you don't have to worry about wicking, and you don't have to worry about the joint, wicking under, sending out solder deeper into the copper, causing a stiff area that isn't supported. Instead, it's all just right there, and it's solid, and it's small, and everything's still flexible around it, and it's electrically strong and everything. I think it might be actually more reliable than using solder. Because, as I said, everything else aside, the stiffness and whatever, solder thermally stresses copper wire. That's well known. Just heating it and then cooling it changed the metal, made it more brittle, made it more likely to fail, more likely to snap. But if you're putting on electrically conductive silver epoxy onto a copper joint of wire to wire, you're taking out that element. You're not heating up with a soldering tip the wire and causing frailty and brittleness in the wire. So the wire maintains its integrity more. And I think that's really good. So that would mean that I would prefer using that over solder. Just kind of to glue the joint together. And it'd look neat and it'd be shiny and beautiful. So I'm just excited, man. Electrically conductive epoxy is the way to go. I think my days of using solder are going to be a lot different. I'm going to use solder probably pretty sparingly. I'm going to use this stuff instead. And it's going to make me way faster. And I don't care if it costs more. I don't think it's going to cost that much, honestly. And at the end of the day, the time saved will be worth it, I really believe. This is very exciting stuff. I just came up with some techniques that are going to turn the whole DIYer scene upside down. Other people will copy me someday, mark my words. And I might release a product of a 3D pen-esque type of electrically conductive ink pen thing. It's not going to be 3D pen though. What I'm saying is I can release a product. Well, no, maybe that exists though. What if there is a surgical needle, a motorized surgical needle? Let me look that up. That's interesting. Wake up. Motorized surgical needle. Press return. Stop listening. Yeah, I don't like this big box and stuff. What I'm describing needs to be handheld, like the size of a pen. The motorization aspect should be all built in. Oh, you know what? It could have a cord. I was thinking mine would be battery operated, but it could have a cord. Cordless might be more convenient though. Wouldn't you prefer to have it cordless? I would. That'd be way better. It'd have a micro USB charging port. Oh? Oh, wow. Check it out, guys. This is they're saying EMI shielding. So basically, uh, you can also create a trace on your board, and then if that's a signal trace and you don't want it to be interfered with by anything, you put epoxy high heat laminate layer to coat it so that it's no longer electrically conductive to layers above it, and then you spread a layer of conductive epoxy over that, and you connect that to ground, and so now your actual positive voltage layer that's sending a signal has a ground plane above it, so that signals going through the air that would try to hit that and interfere with that are now grounded away. So you can actually coat, you could have ground, like you could have copper clad as your ground plane. You can put your positive, you could put a laminate layer above that, you could put your positive signals all above that, and then you can laminate the positive signal and then put paint on another ground plane just above each trace, and then connect that to ground. So you have ground, and then signal, and then ground. So no EMI, no waves traveling through the air can hit and affect that signal. So it'd be the cleanest thing ever. Wow! You can have some clean stuff, man. No interference possible. That is awesome. I get it. And you're just painting it in layers. It's like electronics become painting, not soldering wire. It's just painting. I've been a painter for years. I've been an artist. This is perfect. You're just painting again. You're just making drawings and paintings. I'm so excited. I like the concept of doing electronics this way. See, in this video, the guy is using a 3D printer to dispense solder paste onto a printed circuit board, which he bought. But I say, why not have it dispense... Oh, wow. I just realized you could use it as a pick and place machine. You could have it vacuum up and pick up parts and put it onto this board. So not only that'd be with a different different nozzle that doesn't have the paste in it, obviously. Okay, so what I'm thinking is instead of solder paste, he could put electrically conductive silver epoxy into the tube, have a much finer output nozzle, a needle, and he could spray out that and actually form the circuits and the pads. He could have another one that's got solder paste in it, and he could solder the components onto that, and he could have another one that has no paste in it that will pick up the components and drop them onto the solder paste. You get what I'm saying, guys? So with the same 3D printer, 3 different nozzles, one nozzle could put solder paste on to a board in order to create all the traces and pads. Additive method, unlike etching epoxy methods to create the boards or subtractive methods using a router to cut out the boards, you could simply put on silver solder paste to create all the stuff. And that, to me, would be, well, different. Better, maybe. I don't know. I think possibly better. Probably similar in cost as well, because you don't have to buy those $7 copper clad boards. Copper is expensive too, so just because you're using silver paste, I think the cost would about weigh out, since you could use just a piece of plastic instead of a board. You could literally just use a piece of plastic because you're putting the traces down yourself. It would have to be a thermally protected plastic like TPFE or whatever it's called. You could use copper clad as well in order to create really nice RF boards for radio frequency stuff that's very sensitive. So you'd use copper clad, and instead of dead bug style soldering for prototyping work, you would lay a full sheet of lamination layer, so high heat epoxy, 2-part epoxy, cure all that, creating a separation between the ground plane, and then you do all surface mount onto that, using silver solder onto that, and then to create all the traces and pads. Actually, you don't even need pads though, is what I'm saying, because the silver paste can just connect all the components. So you could have a pick and place, drop all the components where you want them, and then the silver paste would just go between them, connecting them all. And the silver paste is an epoxy, so it would glue them down at the same time. So you actually wouldn't need pads, which would save on quite a bit of material, since you only have to draw the traces and then just draw a little blob onto the component itself. And you can do multi-layer boards. So after you do all of that, you could have it spray on 2-part epoxy, or brush it all on, covering everything, all the traces, and then have it run another pass, sending more traces that could even be crossing those traces, because it's another layer and it's not electrically conductive to the layer before. So you can build up the layers that way using additive method. But I do like this idea of using this. So you could mass produce then with the 3D printer. The 3D printer could then be used as a pick and place machine, a solder paste machine, or if you want to do it the way I'm describing, you could use it as a silver trace making machine. So you could put your substrate down. It could be a piece of cloth if you want. Doesn't matter. You could literally use just a piece of nylon cloth laid down flat. pulled taut on the edges and clamped down. And you can make your board on that cloth. And then go from there. But I would use most likely a rigider material than that, like a sheet of plastic. But it has to be plastic that it doesn't have a low melting point. But yeah, you'd squeeze on silver paste that's electrically conductive epoxy to make all the traces. And then, no. The first thing you do, okay, you put down like a sheet of plastic. TPFE is what I keep thinking of. I just saw an episode on Shark Tank where they created a camping stove made of a sheet of metal that goes over your propane burner and then plastic that folds up into a bowl shape. And that plastic doesn't melt. You could even use it on a campfire. It's very high temperature melting point plastic. I think they call it TPFE. It's something like that. I'd have to look it up. But you could use a sheet of that. You could just buy it by the sheet or whatever. But it could be any plastic. Just a flat plastic sheet. You lay that on your hotbed of your 3D printer. And you have a syringe connected to your 3D printer. A couple syringes. And you have it use one syringe at a time. So you could have multiple syringes next to each other. So they could all work. But only one active syringe would be used at a time. The active one could start out being just an empty syringe, and it will just lower itself onto a part, which you could have lined up on the side, and it could have computer vision to actually line up with the part to grab it. The syringe could lower down, it could open, creating a vacuum, which would suck the part taut in it, lift it up, move it over, and drop it into place. And so you can have it lay out your board layout with all the SMD parts using that technique. Basically vacuum sucking it up and placing it. With a normal 3D printer, desktop 3D printer, it would lay all the parts out in whatever configuration. And then the other syringe would be used then. So the vacuum one would maybe lift up, and then the other one would drop down. And now the second syringe would be the silver paste one. The silver paste one would draw the lines connecting each SMD part. And it would have a very fine needle nose tip. And it would have even pressure, and it would press down, dispensing very neatly like beads of caulk. It would dispense the silver paste epoxy. Now you turn on the heat bed, and it would cure the heat-sensitive silver-based one-part epoxy, having all the pieces then become joined to that permanently. There'd be no soldering involved, no baking involved. Well, I guess you could call this baking, curing that epoxy step. You could also use a heat lamp to set the temperature too if you wanted it to be set instead of through the hotbed. It would be set through the radiative light of a heat lamp. Okay, so then that would cook the epoxy, solidifying it, and then you'd be done. So that's 2 steps and then bake. And that's going from a board to an actual printed circuit board with components installed. And that's only 2 syringes needed. There's no solder paste needed because there's no soldering happening at all. I think that sounds like a great way to do it. Yeah, you can add any material you want in a 3D printer. You can see how he did it here. Here's a 3D printer. He just unbolted the normal 3D printer filament extruder head. And then he just created a little 3D printed attachment. Screws it on. And then he just puts on his syringe system. It's that easy. You can put anything you want. You can see right here. So I'm proposing you just put a couple syringes. You could put smaller ones. He's got this giant syringe. I don't know why. Like, you could use, you know, a much smaller one that's used for like injecting medication for diabetics and stuff. And it's got a motor connected and everything. And so a couple of these things, one could be used to lay down silver solder paste to create your traces. It's an additive method. The industry standard right now is through copper etching. You use a sheet of copper clad board, and then you pretty much glue on a you attach a laser printed diagram of the schematic and then use that protects all the traces you want to keep, and then you put the board under acid and you agitate it and you wait until all the acid dissolves away except the parts that you masked out, and then you peel away the masking and then you have nice shiny copper left just in the traces and pads you wanted. And then you have to let that all dry, and then you have to put on solder paste on everything, and then you have to drop the parts, and then you have to bake it. But what I'm proposing is just using any old sheet of plastic or fabric or whatever you want, and just laying all the components down, and then just using epoxy silver to join them all, and then just letting that epoxy cure with heat, and then you're done. And you can do that by hand as well, but this is a way to do it with the machine, and you can make boards that way from home, the whole thing, in just 2 simple steps. This video is giving me a lot of good ideas. That's incredible, man. A pick and place machine, all with a desktop 3D printer that costs under $100, which I already have 2 of them. Ooh, he's selling it. 125? Oh my gosh. My soldering station costed that. This is well worth it, I think. This is so much better than a soldering station from Radio Shack. All that does is just heats up my stupid soldering iron, which I'll never need again. With what I'm proposing using this machine, I would never need to solder anything again with the soldering iron. I would use this dispenser as a hand tool to use solder paste to make traces. I would solder all my components, all my wires and everything using solder paste. I would never use heat, except to cure the solder paste. I mean, not solder paste, I shouldn't be saying that. Silver epoxy. Electrically conductive silver epoxy, that's what I meant. I would use the handheld version as electrically conductive silver epoxy applicator tool, and I would create all of my circuits by hand using that. And if I wanted to mass produce circuit boards, I would have my 3D printer lay the silver epoxy down and also pick and place the parts and use it that way. But I could do it by hand or with a 3D printer. No, the solder paste does not harden with heat, but silver solder does, and that's what I'm looking to buy. And I'll show you that here. Here it is. It's sold by a company called Atom Adhesives, and it's silver conductive epoxy, and I just watched several videos about it. It is incredible stuff. I don't know if this is the stuff. They have a lot of videos. Flexible silver epoxy adhesives. Oh my gosh. They have a version that's flexible? Holy crap, that's good because that would make it less likely to break. You could create flexible circuits then. Holy crap. It's even better. You could bake it with a heat gun, or you could bake it just under a heat lamp. Heck, I have a heat lamp right here. Here's a heat lamp, guys. Right here. That's a heat lamp. And I just took a normal office lamp. I cut off the what do you call it? The shade part that goes over the bulb, because that would melt otherwise. And this thing, you could just put this thing above it, turn on the lamp, set the distance, measure the heat with your multimeter, make sure it's an exact 150 degrees Celsius and no hotter, and then just cook it. And that's how you'd cure your silver epoxy. It only takes like half an hour. You literally would not need to ever solder again. This stuff is a glue. It will glue your parts, and it's more conductive than copper, and it's more conductive than solder. It was 0.00001 ohms of resistance per centimeter. It's ridiculous. It's amazing. And you could just apply it through a syringe with a motor and your 3D printer, or with a motor through a syringe with your hands to get a nice even flow. It would be just like caulking your bathtub. The key to caulking a bathtub is to squeeze the caulk handle at a fixed speed so that you can lay a nice clean bead. And the same exact thing would apply. You can use different sized needle dispenser output points to lay different thicknesses of wire traces. You could use really fine needle to lay very tiny traces to connect to like a TQFP output microchip with very fine pitch pins. You just draw them in, and you'd have a finger switch to activate. And you'd press the button and it'd start drawing. You could set it to go real slow, so you could just draw real slowly. So you can make hand-drawn circuits that can be flexible. You can draw them onto a t-shirt, you can draw them onto a pipe, you can draw them onto your wall. You can create an entire computer on your wall, on your drywall. That would be flexible. So you can put it on flexible surfaces, you name it. And all your components. You can do it on your 3D printer, pick and place, whatever. No soldering needed. Silver epoxy is a godsend. It's called AA Duct 916. That's the flexible version. It hardens with heat. 120, 150 Celsius, and it fully cures. The 3D printer would not melt the silver epoxy because the silver epoxy actually cures, and it's designed to handle high heat, and it doesn't melt. It actually wants heat to cure. Also, the 3D printer bed can be set to the temperature you want. You could have the bed temperature set to 0 if you're not wanting to bake it yet. Until all the circuits are made, then you could turn it on. But you might not even want to bake it from the bottom. You might be better off to bake it from the top just by, after it's finished printing, you turn it off and you just connect a heat lamp above it. Like I just showed you my heat lamp. You just connect that and it'd cure the whole circuit. I wouldn't bother with the heat gun because that might blow a piece out of place. Just use radiative heat rather than convection heat. A heat gun heats the air. A heat lamp sends heat as waves, and it heats only the surface it comes into contact with. It does not heat the air. So radiant heat, I think, is better from a heat lamp. I know, it does seem too good to be true. Why doesn't everybody do this? How much is it? $13 for a little packet of it. Of the adhesive. Or it's $12 in free shipping. and you get a little packet, and this little packet, if you don't use this for long stretches of wire going across your room. You use wire for that. You use this for microcontroller level stuff, you know, creating tiny circuit boards for control. You don't need a breadboard. You don't need solder. You don't need to order PCBs. Nothing. You just lay out your components. You take a little pen and you draw the circuits with your pen by hand, and you can make the finest stuff under a microscope, the finest little traces with this, and they'll cure, and they'll be more conductive even than copper. You don't have to etch copper boards anymore. It's not a subtractive method. It's a additive method of creating your own PCBs and repairing PCBs rather than soldering on jumper wire to mod a gaming system or something, or making a repair to a circuit board. You just squeeze this on like you're squeezing on caulk, and then you stick a heat lamp on it for half an hour, and boom, you just connected something to something. If you have a torn pad on a circuit board, you just sand off the pad, grind it off with a dental pick, and then you just squeeze on this stuff and you can create a new pad, and then you can solder the parts back on. If you have a torn trace, you just cut it off clean, scrape away a good piece of trace with the dental pick, and then you overlap the good trace, and then you create your own trace by hand with your perfect pen with a surgical needle output of precision, and you can set the speed, and you can practice a little bit, set the speed with your controller, and the controller is right here, guys. This speed controller, only $125, comes with the motorized dispenser, the needles, and everything. I'm making a video about this, and I'm going to promote the heck out of this thing. I was going to make my own this, but this thing is so well designed, I think I should just buy it. I think that's worth it. Well, should I buy it or make it? Crap, that's the ultimate question always. Buy it or make it. I'm a maker. I should probably make it. Shoot. I should make it. Shoot. I'm a roboticist. I can do this with Arduino. I do not need to buy his kit. I don't need to buy it. I can make it, and I can connect it to my computer by USB. My computer could control it. I can make it. So I'm not going to buy this, but if you guys don't feel like making it, you could just buy this. Chips from Mexico. Help a Mexican out. This guy's smart. He's hustling, and he's selling a product that's amazing. You buy this, and you buy the silver paste, and you've got yourself a hand-drawn circuit-making assembly line for $125 plus $13. I don't think I should buy it. I think I should make it. I've already got surgical needles right here. Heck, I got them in arm's reach right now. Right here. All I'd have to do is just connect a motor right here to a string, and then connect the string to here. When the motor pulls, it's going to put pressure down. I could set the speed of the motor with the motor controller. I could put a little tiny Arduino on here. I could have it powered by an onboard battery. I could just hold this and just use it as a pen. It could be wireless. His is not wireless. Mine would be superior in that regard. I can make this. Not a problem. This other guy was making these devices too. Right here. He made one, and you just attach your plunger onto this thing, and you can mount it. It's a USB based one, but he stopped selling it. He lived in Slovenia. But he told you how to make it on his Hackaday project, which is right here. It's a solder paste dispenser, but I'm proposing not to use it as a solder paste dispenser. See, there it is. I'm proposing to use it, instead of a solder paste dispenser, to use it as a silver electrically conductive epoxy dispenser to actually make circuit board repairs and make circuits from scratch. Mailbox, I'm not sidetracked because this will actually help me on all of my electronics projects to increase my speed of productivity 1,000-fold. 1,000-fold. You know, it might not be a bad idea to actually see how he built this. I like his design. I could modify it, but I could look at his plans maybe. What's the con? I'm not trying to sell anything. I'm telling you guys where to buy it. I'm telling you what I'm buying. I discovered something that I'm wondering, why do people mess around with jumper wires and soldering when this is so much easier. You can draw with a surgical needle level of precision. You can just draw your electrical joints. And it's more conductive than copper. It's actually superior than doing jumper wiring to connect circuit boards. Actually, I did see a YouTube video where they do it. Let's see. No, it was, you had your chance to discover this. It was on Linus Tech Tips. So that, if you're saying like, why can't I find this? Well, Linus Tech Tips, if you watch that, you should have seen it. What the hell? Let me find it. Hold on, guys. See, they didn't use a motorized dispenser, so their results were sloppy, and they made the product, or this way of doing circuits, look kind of lackluster. But if you have a motorized dispenser, you would get a perfect bead. And they use it to fix a mouse, and it works. It's perfect, guys. Hold on. Son of a buck.
What they are intended for use.
Alright, check it out, guys.
Or maybe even some forms of wood. They're a ton of fun to play with and maybe able to do quick tests of circuit board layout design, especially if you use something like 1, 2, 3 design, because you can easily integrate electronic ink modules, which will make things a breeze. Anyways, Harry and I are going to try our luck with our MD chemicals panel. Let's see how this goes. Shake well.
The AA Duct 2979, 1 part electrically conductive silver epoxy. You're gonna see it can handle negative 40C to 175C without melting. That's plenty. For example, at 100C, a servo motor melts and destroys itself. So 175C, that means it can take more heat than the other parts of whatever you're building would take anyways. Most MOSFETs fail before that. Most transistors fail before that. Like, that means it's plenty able to not melt. So yeah, it might have a lower melting temperature than copper, but it has a higher melting temperature than every other component in your system. So that's not a concern. It's not going to melt. Alright, that's the only thing I don't like, 6 months shelf life. Sometimes I don't work on electronics that often, so I wouldn't want to buy a large amount of it, because it would just dry up pretty fast for me. Although, you know, that might be their conservative estimate. It might work after a year. You know how epoxies are. The manufacturer will never admit that it actually lasts longer than they say. They just want you to throw it out and buy more. That's why they say it's such a short shelf life. They have a actual incentive to tell you that, you know what I'm saying? This is an application where it would have been amazing right here. So this guy has a trace that ripped off, very fine pitched processor. He removed the processor already. But you can see all these little pads, they're very tiny, that the processor will solder onto using drag soldering. And you can see here one pad ripped off. Now he's going to actually cut a little tiny hair of copper, apply 2-part epoxy adhesive right here, and then he's going to put the piece of copper onto there in order to epoxy it on. Well, no, first he's going to put the little piece of copper down that he had to hand cut with an X-Acto knife out of a sheet of copper, very thin sheet. And it's going to have a little fork coming off of it, the sheet he cuts off, a little 45-degree angle. He's going to solder it onto this existing good trace. Okay. and then he's going to peel it back, put down epoxy under it, and then he's going to push it down onto that 2-part epoxy and let it cure. Now he's got a pad back. And now he's going to, well, I guess he's done at that point. He'll pre-tin it. But the point is, if he had a silver pen, a silver epoxy pen, he could just draw a line like this and be done. He just draw it, heat treat it, and it'd be done. He doesn't have to tediously cut out a piece of copper and glue it down. It cuts out a lot of steps and complexity. Now let me show you guys somebody that actually does it with a silver pen. They actually do what I'm talking about.
You can do everything from now available at a more affordable.
Check it out.
The Cooler Master NovaTouch TKL utilizes genuine Toper hybrid capacitor switches and is now available at a more affordable price. Click now to learn more. These pens are used to quickly, easily, and effectively repair PCB traces or make new ones entirely. You can do everything from fixing a relatively simple PCB's damaged traces, like we'll be doing today, all the way to more complicated stuff like automotive rear window trace repair and prototyping of small devices.
Now, look at this pen. This is key. 0.005 ohms of resistance per centimeter.
Conductive pens. I really don't think these different categories have names, but I'll divide them into squeeze and push mechanism and the roller ball mechanism.
Okay, now let's go over that. A rollerball mechanism would require too large of an output shaft. That would draw traces that are too big at a microscopic level. We want to be able to create all the different levels. Traces nice and wide, all the way down to microscopic traces on a fine-pitched 300-pin output circuit board, or flipping upside down a 300-pin output BGA board and being able to draw traces off of the little pads on the bottom of that. Rather than having to reball it, you would just draw lines off of it to fix a computer. That's far superior. In fact, reballing would be a thing of the past. You just put a little ball of silver paste and push the board down and heat it up. You don't need to reball a circuit board. This stuff would be better for that.
I have, and similar pens from brands like Circuitwork, Skig Laboratories, and Circuitmatic all fall under the squeeze and push category.
Okay, so squeeze is bad because if you're squeezing, you cannot physically squeeze at a fixed pressure to create a perfectly flawless circuit tracing line that is uniform in thickness, because you just don't have that level of precision. But if it's motor controlled pen, it could have extra precise precision. You can create flawless lines. Does that make sense? So that's why a motor controlled version is better. And you can see that people have developed that. And here's one. And all the plans are for it on Tindy. Just Google solder paste dispenser version 5. It's on Hackaday. He started selling it on Tindy, and then he stopped. The project went dead. He stopped selling it. Here was his Tindy page. It's a retired product, but I would have bought this in a second. He actually had 61 orders before he closed down. He lives in Slovenia. But he includes all of his plans on his Hackaday page, and he has extensive notes on how he made this. I don't think you would really need that, but I think it would be valuable. Why not use his design, since he spent a lot of time in research learning how to do it. He has positive customer reviews. Why reinvent the wheel when you can just see exactly how he did it and make your own? And this thing actually just will mount up to a syringe, and you can use different size needles on the syringe, so you can have big traces or small traces. You can determine and dictate the amount of precision you want based upon the needle size. And you can get needles of all different shapes and sizes. You can get needles that are like this, a huge needle that's used for feeding rodents, all the way down to needles that are like this, used for medication. And this has a very fine tip needle that is used to actually enter your skin. And if you this thing's designed to cut through skin, so it's cut at like a very steep angle, but you could just grind it down with a file or very fine sandpaper to create, just like when you cut a tube of caulk, you might cut it at a 45 or more of a steep pitch depending on how you want to lay your caulking along a bathtub. You could cut your needle tip to have the pitch you want to lay your caulk of silver conductive paste. So this is a project I'm going to do. I love it. I don't like the joystick design per se. I'd rather have just a button that I press with my index finger to start it, and then I'd like to have like a little potentiometer next to it that I can turn to change the resistance. The microcontroller would then pick up the new resistance, and it would see like, okay, I need to go faster or slower. I liked the design of this board as well. This has pulse mode where you can have it dispense, pause, dispense, pause. That might be nice for certain applications, but if I want to dispense pause, I could just press the button and let go. You don't really need that, but it's kind of interesting for high speed putting down solder paste on individual pads or something like that. Like if you're doing this type of work, just putting little bits of solder paste. So that'd be kind of cool. Let me answer this question here. So let's say I wanted to run LED rope lights on my stairs and then continue the RGB lights in another location. Could I trace or draw the RGB wires that would normally be visible to continue the circuit to the next string of lights? Yeah, you could draw the wires right onto your wall if you wanted, and you could paint over it to hide it. Heck, you could do all the electric for a ceiling in your house by painting the electrical lines with silver traces and then paint over it with house paint and actually run all of your LED lighting in your ceiling like that. That'd be hilarious. You wouldn't need to work with wiring. What I'm doing to wire my LED lighting for our basement is I'm masking taping on wires onto the ceiling, and then I'm going to plaster over that and bevel it out so you can't see the wires, because I don't feel like cutting channels in the drywall and making the house fill with plaster smoke. So I'm just adding the wiring onto the existing ceiling without cutting into the ceiling. But this would be even flatter than that. You could just paint on it instead of having to put wires down. If you want to insulate the wiring, you would simply paint on a rubberized paint, then paint on your silver epoxy paste for the conductive layer, and then you'd paint on a rubberized layer again. But latex is a rubber, so all house paints are actually that. They are latex rubber. They would prevent conductivity. So just putting it directly onto the ceiling of your house, which is painted in latex, then paint it again with white. Just paint your whole ceiling white again, and boom, you don't have to do any plastering. You could just use this paste to do all your wiring. But that would get pretty expensive at $13 for a tiny little amount. So I don't think it's practical for long distance. It's more practical for tiny applications. It just would get too expensive. I would use it on printed circuit boards and tiny, building cell phone size circuit boards. Stuff smaller than a credit card, because it just would get too expensive otherwise. The paste, what is it called? Silver conductive epoxy. Just search it on eBay and you'll find these little packets. You don't want to order it in bulk anyways. You want to order little tiny packets like this, because this size packet could make like 20 circuit boards. Like this is a lot of paste if you consider the fine little traces on a circuit board and how thin those traces are. It's like nothing. It's tiny. So this packet would go a long way. And it only costs $12 in free shipping. and you want to put it in a syringe. And you can squeeze the syringe by hand, but I do not recommend that. I would far recommend making a syringe dispenser or buying one. For only $125 you can buy one on Tindy. It's called a DM solder paste and adhesive dispenser. It's motorized. It comes with a motor controller. You can set the speed on a LCD screen, and this motor turns and it presses the plunger down perfect, and you can connect any size wire out to this. I mean, any size needle, and it comes with a bunch of needles, but his needles aren't really fine, I don't think. Maybe that one's fine, I don't know. But you can use surgical needles for this. See, this is $125. The reason I don't want to pay it is this. You can get a syringe, a much smaller one. You don't need a syringe this big. That's impractical. Just use a normal surgical syringe. A normal surgical syringe you can buy in a pack. You can buy a 10-pack for like $1 in free shipping. So that's $1 in parts. A motor, I don't think you need a motor this big, but a motor costs $1 or $2. Let's say $2 for a DC motor. It doesn't have to be a stepper motor. So that's $2 plus $1. That's $3 for the motor and the syringe. And the syringes come with these output tips. You can buy extra output tips for, I don't know, 10 cents each. So we're up to $3. And then you just need an Arduino Mini, which is $1, is the motor controller brains. And you need a little motor controller H-bridge chip, which is another $1. So that's $3 for control systems. And then you pretty much just need to wire that or program it and then wire it up to a button. So a button's another, I don't know, 10 cents. The point is, for crying out loud, you can make this for under $5 and he's charging $125. And that's why I don't want to buy it. Because you can make the same thing and you don't need an LCD display. You can connect it by USB to your computer to change the settings on the microcontroller. Your computer itself could change that. So, yeah, the total parts to make this kit, to do everything he did here, would only cost $4 or $5 in parts. Now, if you already have your own syringe, which I do, your own motors, which I do, your own Arduino Nano, which I do, like, if you already have everything, I don't even have to buy anything. I can just literally make this for free with stuff I have on hand. I'm going to be making mine very soon, the next electronics day. This is my #1 priority now. As far as electronics goes, making this thing with the silver paste is going to make me not need solder. It's going to make solder a thing of the past. I can throw away my soldering station. Like, soldering is stupid once you know about this. It's stupid. Why would you ever do that? Soldering weakens wire. I just glue wires together for joints. Conductive glue. Solder thermally stresses out wire. It makes it brittle. I'd rather just glue it. I would glue it with this. Atom adhesives, silver conductive epoxy. This stuff is strong as a tank. It can handle like 400 degrees Fahrenheit without being damaged. It doesn't melt. It can handle 50 degrees below zero. It can handle Mount Everest or outer space. It's used by NASA. It won't crack under vibrations because it's epoxy. Epoxy doesn't crack like metal does. It could be submersible if you put epoxy lamination over it. All you have to do is pot your electronics. It's called potting. You put silicone over your electronic board when you're done, or you put lacquer, or you put a 2-part epoxy adhesive which completely waterproofs everything. And then it'd be submersible. But normally when you submerge electronics, you first would build a container for it that's sealed off. But another way to make it submersible is to use adhesive transfer tape with nitrile rubber glove attached to it and then just put that over your circuit. This is completely waterproof. And I make these little squares all the time, waterproof squares. So my squares that you guys see me cut off all the time can be used to make electronics submersible. But that's just one way. That's a removable way, which is why I like it more than potting. Because potting, how do you make repairs to the circuit board or improve it or change it? Once you drop it in a vat of glue and it hardens, you're done. Like, you can't repair it. But adhesive transfer tape is waterproof and removable, and it doesn't even leave a sticky residue. It just pulls off, and then you could do repairs to your board. So it's a really awesome solution. So anyways, I want to show you guys some people that actually use this technique to fix a mouse. Check it out.
Before actually pressing the tip onto the PCB, in order to have the silver ink come out of the pen when you pressurize the pot. The rollerball pens, like the Electron Ink, get it? Anyways, they're super cool, but not really intended for use on PCBs. You may be able to get
But a technology that's being underused, and everybody should be using this instead of solder, because it's way better, it's superior to copper, and you shouldn't have to solder wires and be stripping wires all day. I spent 90% of the time working on electronics just stripping and cutting wire. That's it. 90% of the time is doing that. With this, I lay out all my components and draw my connections. Draw them, like with pen. That's it. I just draw them all in. And then I just put it under heat lamp and it's done. Why the heck would I go back to jumper wire?
They're a ton of fun to play with and may be able to do quick tests of circuit board layout design, especially if you use something like 1, 2, 3 design, because you can easily integrate electron ink modules which will make things a breeze. Anyways, Taryn and I are going to try our luck with our MG cordless pen. Let's see how this goes. Shake well, lift it well, yes,
the pen would disperse the paste well. Why wouldn't it? Oh, you mean the ball within the pen wouldn't turn because the surface board is too slick? Kind of like when you try to draw a pen onto tape and the pen doesn't really let the ink out because it kind of like doesn't spin on the tape. That might be what he meant. I get it now. But he needs to explain that. He implied that just because it's a pen, it won't work. He should say it's a pen, so it won't work because the ball of the pen doesn't turn if the surface you're applying it to is too slick. That's a very big difference than implying that the ink itself will fail under a pen type dispenser nozzle. That is what I took away. So that's a great point. But you know what? You don't have to worry about any failures if you have a dispenser like this. That's a motorized plunger system. Takes too much force, especially with fine dispensing needles. That's right. And you know what? You know what happens when you put too much force? I'll show you what happens, guys. The joint comes out disgusting. Watch. This is silver conductive ink, by the way. Silver conductive wire glue paste. This guy's going to try it. He's going to use the plunger by hand. You're going to see it's going to come out horribly. And videos like this get 25,000 views, and everyone's saying it is like, oh, why would I use that ink? That could never make clean traces for my repair work. Because he's using it by hand, it's going to spray all over the place and make an ugly trace. If he had a trace applying motorized pen like this, or like this, or like this, with a motor on the top, see, then he'd be able to apply it with tremendous precision and uniform pressure, which is the key. If you've ever worked with caulk in a bathroom, you would see that uniform pressure applied to a plunger is the key to consistent, clean beads of caulk, which is important if you want to do a good job caulking something. The same exact things, principles apply. Let me go back to that video. Here we go. Watch how disgusting his trace is going to be. It starts out pretty good, but then he presses too hard. And then a big goop comes out. Oh, didn't press hard enough. Oh, then it comes out too fast. Like, it's sloppy. And look how big it is. See, that's unacceptable work. That's very bad. Also, he made another mistake. Whenever you release, you have to press down when you release, not lift up. He lifts his... See, he's lifting it up when he releases, watch. If you've ever worked with caulk, you know press down and relieve pressure and then lift away to draw the caulk back in, and then you release it. It's precision work. He's doing a bad job. This is bad craftsmanship because he's using bad technique. But don't let that fool you. This can be used to repair circuit boards. Or make circuit boards. Look, see, he pulled it back and it created this little bead, and that would be a short circuit if you were doing this on a circuit board. That would mess you up. See, that was a mistake. And this all looks terrible. It's not clean. But with the uniform dispenser, with a motor, it would have been perfect. Now he'll show how hard it is. Now he'll show the resistance, which is 1 ohm at a centimeter. Yeah, this resistance is unacceptable, and he put a thick bead down too. This is unacceptable. But he bought it from Banggood, and he bought a silver conductive wire glue that's mostly wire or mostly glue with very little silver. If you look right here, the quality pens, which cost a little more money, have a resistivity of 0.005 ohms per centimeter. And so you just have to buy the more expensive silver paste that has a higher silver content. If you buy it from Banggood, they're going to put very little silver in, and it's going to have tremendous resistance, and it will be unusable. So that's the difference. You have to make sure to buy the good stuff.
Okay, I'm not gonna blow on it. Oh my. If you got that dead laptop, so you're gonna want to practice more and think on an actual PCB, because you might have to test. This is the one that we dropped during that commercial. A little bit too thick. I think you wouldn't braid some traces that way. Just right over here. Okay, let's try to scrape that back. Oh, hey, those are perfect. Yeah, you're not using an ESD safe tool, sir.
Okay, now when he says I might have created a bridge, to avoid that, all you have to do is put down lacquer or whatever on the layers below where you're going, and that will laminate it, and so bridges can't happen. So in this way, you can actually create wire traces that are overlapping multi-layered. So you can put a wire trace, and then you can put an insulative layer, and then you can put a wire trace, and then an insulative layer, and you can build up, and you can send as many as you want through a tiny area without short-circuiting, because you would insulate each layer. You could create multi-layer boards this way. The good company is Atom, and that's what they're selling on eBay. They have, this is the company, Atom Adhesives. They're the best in the world. And at silver conductive epoxies. And you can see very clearly how good they are based on their videos where they have testing done by NASA and everything. Look at this. This is all Atom Adhesives. These guys are the real deal. They're the manufacturers of these adhesives, not Banggood.com. These people sell to NASA. So there you go, guys. They drew it in sloppy. Look how fast he's moving his fingers. Like he's drawing a sketch on paper. Like you should be drawing very slow, not drawing it, wiggling your hand back and forth like you've got Tourette's syndrome. Like, and yet he still gets successful results just putting it on like an idiot. So that just shows you don't have to have any skill to do this.
It's just not very precise. Yeah. You can almost do like
He's complaining it's not very precise as he wiggles his arm back and forth like a dog's tail and it's excited. Of course it's not going to be very precise. If I take a pencil and do the same thing, is that going to make a perfect line or a scribble on paper? This guy's fully retard.
Look at that. Okay, we only have one left.
Another reason why they're not being precise is they're not using any magnification. You just saw their head right next to it. You need to use a microscope or a visor.
I don't think that was going to work. Do you want to try that before doing this run? Because it doesn't like, oh, try actually doing it? No, try, well, okay. So the issue that it was having, motion worked fine. The clicking of the left mouse button, however, was playing.
Alright, TLDR, they're about to test it. The mouse is going to work flawlessly, by the way. And then people in the comments, which I was reading, were raving on and on about how amazing it is. And then other people are saying, I just solder wires to it. Okay, you idiot. That's the slowest possible way you can do it, and you can also damage other stuff. And it takes tremendous skill and expensive equipment. This, you just draw it on. This is so much better. Those pens are too expensive? That's a lie. That's a lie. You can just buy the ink for $12 and put it in a surgical syringe. Wake up. You can just buy the ink for $12 and free shipping on eBay and put it in a surgical syringe, which costs less than 50 cents. Period. Obviously, not enough people took on to this because 3 years ago this video came out, and I haven't seen the entire maker movement using exclusively silver ink, and that's a problem. It means that people don't think this is a good solution. So people reading through this comment section like me need to see my posts and be like, oh, snaps, like, there's a better way. In fact, I'm going to put this post as a non-reply, as a page comment. I don't know if that'll be an issue or not, but I want people to see this. I'm upset that everyone's not doing this. Holy shoot. Look at this. Silver pen resistivity 0.0001 ohms per meter. This guy thinks it's easier to use wire. That's such a stupid statement. It's not easier than just drawing it with a pen. You don't even need to have a soldering iron. Just jumper the wires, so much easier. That's a lie. You have to strip and cut wire. You have to tediously apply flux and paste. This is 1,000 times faster than having... Wake up. This is 1,000 times faster than having to cut a copper wire to the correct length, comma, strip the copper wire, comma, on both ends, comma, pre-tin the copper wire, comma, pre-tin the traces, comma, apply flux, comma, turn on and warm up your soldering station, comma, get out the appropriate length of solder, comma, apply the solder for 2 joints, comma, etc., period. With this, all you do is draw a freaking line, period. How the hell did this not catch on more so within the maker community, period? It should be all anyone uses by this point, period. Yeah, fluoride. With longer application, you want it to be thicker, the thicker trace or thicker wire. So that there's less resistance. But no matter how far when you get really far, the resistance adds up for any type of situation. So for really long travel, you want to use higher voltage, which can travel further distances. Also, for really long travel, you want to eventually get into AC voltage instead of DC. But when just dealing with a circuit board or a robot, the resistance in the wire is not enough to be game changing for long stretches of wire, because it's not long like crossing a whole town type long. But the amount of resistance in the trace is pretty negligible. You pretty much choose the wire thickness based on the amount of current you want to carry. The resistance of the wire doesn't make a huge difference. But like, if you're trying to send high current, you want to have thicker gauge wire. If you want to have high current printed circuit board traces, you want to make the traces wider to handle that amount of current so they don't get too hot. See, overpriced hipster silver pen or cheap solder. That's how people are seeing it. It's not hipster. It shouldn't be seen as that. Silver pen should be all anyone uses. But I say it shouldn't even be a pen. Really, what people should be using is a motorized syringe. That's the way to go. Motorized syringe. And you're good. Not a pen. Every automotive technician should have silver ink pens and not have even own a soldering iron. You don't need it. If you have silver conductive ink, you don't need solder ever. Wake up. Every automotive repair guy should throw away his soldering station and buy a silver solder and syringe. Epoxy to apply it with, and he would never have to solder again. Period. Won't let me reply. I think you gave up on this concept too early in your career, period. This is far superior than the method you just described, period. If you're worried about the trace wiping away after it has cured, comma, then you must have been using really cheap epoxy silver, period. The really good stuff is used by NASA and is very strong and can even come in flexible varieties, period. You should do some research, period. You can also coat it with 2-part high temp epoxy laminate layer to prevent it from ever coming free. What do you mean permanent solution? It is permanent! Gosh, this is angering. Why are they saying silver epoxy is not permanent? Of course it's permanent. What do they think it's going to do? Jump off the PCB and run away after a couple years? Thank you, Elite Gamer. Yeah, I don't know why nobody's using it. You said it came out 15 years ago. It's not being used at all. I can tell you that for a fact, because I've watched thousands of electronics repair videos and electronic DIY and maker videos, from Ben Heck to EEV blog to guys like Voltar and uh, Louis Rossman, um, a new guy I just found is incredible. This guy's incredible. Retro Game Mods. He's just awesome. Um, and none of them are using it, and it blows my mind. And it's just gonna work. I'm gonna use this guy's documentation to create this project. He stopped selling it on Tindy. His listing went offline. Unfortunately, it's retired. But he made a whole Hackaday page documenting the whole thing. Uh, and it's very detailed with instructions, discussion, and documentation, and videos. And you can see the little motor right here, and I can copy all of his designs. I don't even have to spend time designing it. I just have to make it. This will be no big deal. So, yeah, man, we're gonna make one of these, and I got all the parts already. I will, Escapade. Of course I will. I'm gonna do all of my electronics videos now doing this, but I can create a video obviously showing, I'll have a video series showing me making this pen product. I'm gonna make a video of today just discussing all of this technology that's been overlooked and forgotten. It should be the only thing used. People shouldn't, as a beginner in electronics, you should not buy a soldering iron. You should buy a silver pen. It's retarded that people do. I'm curious though, can you solder to a trace created by a silver pen? That's interesting. Wake up. Stop listening. Oh, I just realized something dumb. If you create the traces with silver solder or silver epoxy, I was thinking, can you then solder on the component? No, you don't need to. You would just silver epoxy on the component as well. I gotta take my mind off the solder thing. I wouldn't create a silver epoxy trace and then solder on the component. I would create a silver epoxy trace and then silver epoxy on the component. So I'm just getting I'm thrown off by all this. Oh, it'll get as hard as the base epoxy is. Different epoxies are different hardnesses. You can get the flexible version, which would remain flexible, or you can get a brittle based version. They come with different formulations. You have to decide whether you want flexible or hard, if you want it rigid or flexible. It's basically just up to you. By the way, they create conductive silicone too. That'd be something worth looking into for flexible applications where you really want excellent flexibility. This is critical. People a lot of times will buy silver epoxy from China and it will contain very little silver. So it will have high resistance because it's not very metallic. It's more glue, less metal. The more particles you put in, the less resistance because then it becomes like a solid piece of metal. So you want to pick a high quality, high silver content one. Okay, so you can actually make your own. Just use any epoxy, fill it with 35%, which is considered large, 35% silver dust, and boom, you can make your own. All you have to do is get a thermal setting epoxy. You don't even have to buy silver epoxy then. You can just buy a normal epoxy and mix your own silver in. That's way smarter. That's what I'm going to do. Forget buying the special stuff. I'm going to make my own. Epoxy absolutely would stick to tar and concrete. If you look at a lot of modern day garages, the floor is made of epoxy over the concrete because that prevents staining. Mechanics otherwise would stain the concrete. It looks terrible. Epoxy can be cleaned better. It doesn't stain. So those nice shiny garages, those are epoxy coated. You would just mix 35% by volume silver particles into the epoxy and then paint it. You could use the same epoxy you're already going to use for the garage. Guys, I'm just going to either buy silver or buy silver powder. If I buy silver, I have to learn how to turn it into powder. Then I just mix 35% of that into the epoxy and I'm good. If I use gold, it'd be even better. But yeah, you wouldn't want to use copper because silver is way more conductive than copper. And since you're dealing with tiny little particles, you want it to be extra conductive to make up for the fact that you're not using a solid piece of metal that's uninterrupted. So basically these particles are not going to be solidly connected together. There's going to be glue between them. So the electrical current has to travel through a web matrix of particles twisting around, and any resistance in the metal itself is going to really cause a lot of resistance since it's just little particles kind of glued together, if that makes sense. So just a solid piece of metal is way better for the electric to travel. So you want to use something that's going to compensate. If you use gold, it would be even better. But that's super, ridiculously expensive then. But I'm sure you can buy it. Gold epoxy. Everyone would try to steal my robot to get the gold out. And by the way, they even said that the resistance in epoxy is more than in copper, silver epoxy. So that calculator I used was wrong because I messed up some of the values. But the resistance is not enough to be a problem. It's really not going to mess up your circuits. You can still do circuits with it. It's just a little more resistive, but you can still do any type of circuits, including RF and high frequency stuff. Doesn't matter. So that's a relief to know. Exactly, Elite Gamer. You have to use silver powder or gold, which is even better, to compensate. Stop listening. To compensate for the fact that it's mixed with glue, which is not conductive, and that means you have to use an even better metal than copper to get the resistance down closer to what copper would have been, solid copper. You know, if you really want to, you could just take a little pile of silver powder and mix it with 2-part epoxy right there. And now you have your little, paint. And you can just dip a toothpick into it and just paint it on like that. Or a fine-tipped artist brush. And you can just paint on all your circuits like that. Talk about cheap and easy to do it that way. That's really approachable for a DIYer. I mean, why do we need it to come out of a syringe? Why do we need it to come out of... A pen. Do we need that for paint? No. You mix up your paint in a bowl, you stick a toothpick in it, and you do paint by number like that. I used to use toothpicks for paint by number because the brushes were crap, and they couldn't give me the accuracy as the tip of a toothpick. A box of toothpicks would be great for this. But a surgical needle with a stepper motor controlling it could make some very fast, very precise lines that would be way faster in application than trying to dip a toothpick every couple seconds. So yeah, I take that back. Yes, a toothpick could be done and it would be acceptable, but I think the button press surgical needle output would be superior in speed. It would just be like the Cadillac compared to that. It would be incredible. But all of these options are a million times faster than trying to use wire. How do you ensure a homogeneous mix? Well, like with any epoxy mixing, you just mix it for a little while. Just stir it for a long enough time. If you stir something for a long enough time, it becomes uniform. The same with baking or anything else. You just gotta make sure you're stirring it for a while. It's 35% silver to 65% epoxy, so it's not like you're not having much silver, and it's not like when you mix baking powder into a huge bowl and you got to stir it for a long time to make sure it gets to every corner. This is 35% mix. You shouldn't have to stir it for that long for that 35% to be very well distributed. I don't think dimes are pure silver, but yes, you could use a pure silver coin. You would just need to convert it to powder. And I haven't researched how to convert metal to powder yet, but I need to do that anyways for when I use electrolysis to apply zinc plating to metal car parts and stuff. I have a brick of zinc I bought, and I need to convert that zinc to powder and then mix that powder with siliconized fumed silica powder. I need to mix my zinc powder with fumed silica powder, mix it with vinegar to create a highly electrically conductive zinc plating solution, and then you just connect your electrodes. These people are such huge scammers. They're just selling normal epoxy, dumping in some silver powder, stirring it up real well, and then marking the price up by 1,000 or 10,000%. It's ridiculous. Oh, thank you. I'll make my own. I'm not an idiot. I can pour silver powder into epoxy and stir. It doesn't exactly take a degree in chemical engineering, does it? What a joke. Save myself 90% of the cost. This will be excellent for creating your own DIY solar panels, which require all those little thin lines of electrical conductivity. You can paint this right onto your solar cells if you create your own solar cells and you can't solder to that powder. Those are usually like pigmented inks that trap the sun, and you can't really solder to that. I don't think this would be great for that. I think making your own DIY solar cells, that's something I was planning to do anyways. The funniest part is you buy this epoxy, which is way marked up from the price of buying just normal epoxy and buying your own silver powder. And then you still have to stir anyways. While you're stirring, you could have been stirring in the silver powder. So it's retarded to buy it like this. Just buy the silver separate and you can save on all the costs of high-tech epoxy. Ooh, that's a fantastic use case. You squeeze a little bit of this onto your crimp connector, and then you crimp it, and you don't have to worry about the crimp being a quality job, because this will make the electrical connection really, really good to your crimp connector. That's awesome! Then you can make the crappiest crimp connections ever, and it just doesn't matter. You're pretty much gluing it together in addition to whatever mechanical aid the crimp connector gives you. Ooh! Oh my gosh! That comment about the lab just made me realize you could use this to glue copper wire onto a car part, and then put the other copper wire into your fumed silica with zinc powder and white vinegar mixed into a paste and applied all over the car part. The electric would run into the paste, through the paste, and then into the ground, which is glued electrically with this electrically conductive glue onto the car part. Then, since electric has to pass through the aqueous paste into the car part in order to pass into ground, and it's all one electrical circuit, that carries with it the ions from the zinc powder, thereby zinc plating your part. I was already going to do this, but I was just planning to press firmly the copper wire against the car part. This will make a really excellent electrical connection to the car part, ensuring a really excellent electrolysis process. So this is actually going to help a lot with electrolysis. Electroplating car parts without removing the car part from the car is my plan, including the bottom of your car. I want to electroplate my exhaust, my oil pan, all rusted parts, everything. And I don't have to remove anything. Forget painting the bottom of the car in epoxy and that chipping away and rust forming underneath the epoxy. I'm going to electroplate it with zinc. It's going to be galvanized underside of the car. That's going to be game changing for the automotive industry, for people trying to get rid of rust problems. After you zinc plate it, then if you want for looks to powder coat it or something, that's a bonus, but the zinc plating would get it completely rust proof. Also, the electrolysis process can be used with this special glue to draw rust onto sacrificial metal using fumed silica and white vinegar as a paste. And you can use electrolysis to remove all rust, and then electrolysis to electroplate all rust. And this is going to be such a huge thing on YouTube. I can't wait. Yes, wires in a watch. You know those are tiny, and this guy repairs them for that. That's great news. So people are using it for tiny, tiny stuff. Oh! That's genius! You can use this silver conductive epoxy to attach wires to batteries, rather than create a battery welder or hold your soldering iron on there forever. It's great for that. That wouldn't be good for precision work when squeezing out of a packet. No crap. You don't do precision work out of a packet. You put it in a surgical needle. What an idiot. I don't want two-part. I don't. There's no way. Because then you have to squeeze them out, mix them, scoop them up, apply them into a surgical needle. I feel like that's just too much. Whereas if I used one part, all I have to do is just keep it in the needle all the time. Whenever I want to solder something, I just squeeze. That's it. Just squeeze. Stop listening. I have to insist that that's the way I'm going to do it. Hell yeah, man. That's how I'm making my printed circuit boards. I just don't like his technique. He's not trying to make it smooth or like to look like a trace. He's just making little blobs. But he's showing how small the blobs are. That's pretty darn small. But it'll be even smaller if you use a surgical needle. Alright, here's a little update, guys. I just spent the entire day researching hardcore. In the end, stop listening. In the end, I'm going to be building a 3D pen-esque dispenser that's based on a surgical syringe that will have a motorized system for the depression of the plunger of the surgical syringe. And instead of the normal use case for that, which is to output solder paste for putting SMD components onto a printed circuit board, instead I'm going to be having it output silver glue. Now, there's silver glue that is $60 for 10 grams, made by Atom Adhesives, ATOM. Rip-off price. You can buy 10 grams of silver for about $10 in raw silver, and then the glue is not worth $50. So that's an absolute rip-off. I will not pay it. I will not pay it even for their 1 gram version, which is even a higher rip-off because that's their bulk quantity sale price. For their extra tiny version, it's even more overpriced. It's like $200 for 10 grams if you buy it in 1 gram quantity or whatever. So I won't come near it. I won't pay those prices. I don't care. All it is silver powder mixed with the glue. The key is to find out what's the best glue for that. And from my research, there's very little in terms of people making DIY silver solder. Actually, I don't think I found any videos about it, so I'll have to make some. I'm going to experiment. I have to experiment because I don't have anybody's guide to follow, and I couldn't find any information, so I just have to straight up experiment. I'm going to be trying, for sure, PVA glue, or aka wood glue, which was something that someone in the YouTube comments section actually said that they have used with success to create highly conductive electrical circuits. So silver powder plus PVA glue actually works. Now PVA glue is water soluble, so you can add water to it to thin it out if you want. From my research, I was able to determine that the silver powder concentration in the glue for a good conductivity is typically between 50 to 75%, with a higher conductivity being closer to 70 to 75% for the really low resistance silver conductors, which is what I think I want to go with. I'm going to experiment with UV cure glue, PVA glue, possibly clear silicone, clear lacquer, this nail polish, polyethylene acetate or something like that I've tried buying. So several different types of glue I'm going to experiment with using 70% silver powder. I bought silver shot. You can buy silver bars, silver bullion. I don't know how you want to search for it on eBay. You just try to find something for about $1 or less per gram of silver. And the silver shot I bought was right around $1 per gram. That's the cheapest I could find. Maybe if you spend $100 and buy a big brick of it, you can get the price down even more, but I just wanted a sample because I'm going to be experimenting. So I will use the silver shot, and I will create a grinding system of some sort to convert those chunks of silver into silver powder for my silver solder glue. I'm probably going to be looking into the way Robert Murray Smith converts graphite into nanoscale graphite. He built a machine for that. I'll probably create a similar machine for converting metals into powders. I also have to convert zinc into zinc powder. Robert Murray Smith has built a machine that I've seen that converts metal into powder, and I'm going to create a similar machine most likely. I'll look at his design and I'll compare it to some other ideas, and I'll come up with a machine that can do this. And using the silver powder plus one of these different glues, it will most likely be PVA glue because I know that works. I'll be able to create basically a silver glue. That silver glue will be inserted into a surgical syringe, and when you depress the syringe, it will apply the glue onto a circuit board, and you can create traces and pads that way. Instead of soldering onto those traces and pads, you will simply draw the trace / pad directly onto the component, or create the traces and pads, let them all dry, then put on the component, then bridge the traces and pads onto the component by using again your silver glue. So silver glue will be how all components are attached to the board and how all traces and pads are created. You can also create traces and pads on flexible surfaces or non-traditional boards. You could even create traces and pads on a wall, anything you want. Now, the key to creating a nice uniform thin trace is a very fine-tipped surgical needle, so I might even need to buy extra fine-tipped surgical needles, the finest I can find. And also the key is uniform pressure on the surgical needle plunger. In order to create uniform pressure, you're going to want to use a motor using PWM to slowly apply firm pressure to the plunger to emit the silver glue cleanly and uniformly. I'll have a button press activator that will trigger the motor to start. When I release the button, the motor will turn the other way and back off the plunger a little bit. So I'll set up the motor to have a pulley system and be able to pull down on the plunger and back it off. And I'll be streaming the creation of this machine. Now, I found a $125 version of said machine, and I found a $260 or $275 version of said machine. I'm going to create one just like theirs, except in my opinion better than theirs, and mine will be for a total bill of materials of about $6, and it's all materials I already have on hand, so I don't even have to go out and buy anything. With this system, you don't have to do any soldering or heating. That's correct. And you'll be able to create electrical circuits as good as a copper circuit board with maybe slightly more resistance, but around 1 ohm of resistance on a trace is what we're probably looking at. And for really small scale stuff, that 1 ohm will be even less because it's 1 ohm per centimeter. And when you're dealing with millimeter scale stuff, it's even less than 1 ohm. And so it doesn't actually impact the function of a circuit or the speed of a circuit. It might run a little warmer because of the slight resistance being introduced, but that's about it. It doesn't ruin the speed or anything. It's just a little more resistance, but negligibly so. Now, with the really expensive, high silver content, expensive silver conductive glue, which costs a lot more than making your own, you can actually get 0.0005 ohms of resistance per centimeter, something crazy, very, very low, approaching what copper has, just plain copper sheeting. So I could buy that if I wanted to, but I really don't want to do that. I really want to use cheaper solutions than that. I don't want to pay them that kind of money because I think they're ripping off customers. I honestly do. I believe you can get higher conductivity just by adding more silver flakes, more silver particles. And so it's a trade-off. You either have more glue and less silver particles and it binds well, or you have lower glue, higher silver particles, but it doesn't stick as well. It's a little weaker because there's not that much glue involved. It's just silver particles with barely any glue. So you have to find a good medium that you're happy with at the end of the day. But I think this can work to make circuit boards this way, and repair circuit boards this way, and repair traces this way, and all kinds of stuff. It's going to be great. I bought the silver particles, I bought several different glues, I bought a dental pick for applying the silver paste, or cleaning up or reshaping the traces that I create with the silver paste. I can use my X-Acto knife, but I feel like a dental pick might be a really nice tool for me. It's a very precision instrument, and I've been watching this guy Retro Game Mods on YouTube that uses a dental pick for a lot of stuff, including scraping off traces to prepare them for solder. He scrapes the laminate layer off of them with that, and it looks like a really nice tool that I could use in place of solder or a X-Acto knife blade tip at times. We'll see though. So I have a pretty good idea of how I'm going to make this silver paste soldering pen. I have a pretty good idea of a couple ways and where to start my research on creating the metal powders from the metal. I have a pretty good idea of several experiments I want to run with different glues to create my own silver conductive glue. I did purchase from eBay a cheap silver conductive glue that has actually pretty good ratings as a low resistance, excellent silver conductive glue. So it was like 1/50th the cost of this rip-off Atom Technologies Atom Adhesives glue. It was way cheaper. I don't know if it's going to be as quality or not. I have no idea. But we'll find out. I bought it and I'm looking forward to trying it out. One negative thing that a lot of people mention about it is it tends to be a little bit on the thin side, a little more of a paint than a paste. But I'm not too worried about that because I believe that I can thicken it up just by adding more silver particles to it to thicken it up. Just like adding baby powder to epoxy to make a thick paste with epoxy, it's the same concept. If you add particles or powders to a liquidy glue, it becomes thicker. It just makes sense. So I'm probably going to do that, and at the same time that will decrease resistivity and increase electrical conductivity. So that really can't hurt. So I'm going to definitely try that, and I'll have the powder. I'm going to be able to make my own. So it was a lot of information, a lot of research, a lot of decision making, but at the end of the day I refused to buy the overexpensive, overly priced silver glues. I decided I'm going to make my own. I looked into that thoroughly, and I also looked into thoroughly making my own dispensing system that's going to be like a pen, and I can just use my hand like a pen to literally draw finished traces on a board and connect those traces to the components, and then start on the other side of the component and continue going. So all I have to do is lay out the components and then just connect them all with drawing with a pen, and then I'm done. There's no heating, no nothing. And then let it cure under a heat lamp or in an oven or whatever. Wait a day or two and it's done. It's ready to be used. That easy. I think that's the ultimate thing, and I'm gonna do it all. Another really cool aspect of these types of dispenser pens is if you empty it out and just have air in it, if you turn the motor in reverse, it will have a suction. When you pull on a surgical syringe, when you pull the plunger out, it creates a vacuum, and that's how it draws fluids in, or draws blood out of you. So using that same method of pulling, except the motor will do it, it will create a vacuum and you can pick things up with it. So you can actually pick up little surface mount parts that you lay out on your lap or on a little table. You can pick up the part with this pen and then put it where you want it and then release the vacuum. And so you can pick and place parts using this thing as a vacuum gripper, and that's so much easier than trying to pick up the parts with the tweezers. So it's just a little convenience thing. The tweezers are a little more finicky, so this will be really nice for that. And that's how actual pick and place machines work. And then as a final benefit, this same pen, and this is really cool, can be mounted in place of your extruder on a standard desktop 3D printer, and you can set the fan motor output to be the output to the button that dispenses the silver solder, or the silver glue. And you can have your 3D printer then output the silver glue onto a piece of prototype board that already has all the components laid out. Okay, so no, actually the 3D printer can have a syringe that has no glue in it and use the vacuum mode where it just creates a suction to actually go down and pick and place all the parts onto your board. So you can have your 3D printer lay out as a pick and place machine your whole board. And then that same 3D printer can have silver glue filled plunger swapped in, and then it can go down and print out all the traces between all those components with overlap onto the component. So you'd have it squeeze glue onto the side of the component and then down onto the board and then across and over to the next component, up and over and onto the next component, so that the component becomes coated in glue on one side and the trace is created between that component and the next. And so using that method, you can have a desktop 3D printer not only pick and place your entire board, but also connect all the parts of the entire board, and you'll have a finished working circuit board with no heating, no soldering, no nothing. All in just 2 steps. And those 2 steps can even be made into 1 step if you just had 2 pens on the same 3D printer, and one can be deployed at a time. So yeah, you just have to have a motor to lift up one pen and drop down the other one for it to be used. So and you probably want to have some kind of auto leveling. I don't know, you'd have to calibrate it pretty well, but this would be totally doable. And so using this technique, I believe I can make my 3D printer make the circuit boards for me. But that's if I wanted to make many copies of a circuit board. what I think is that for any small electronics project, I really don't want to deal with setting up a printer and setting up all these files and creating G code. That's worth it if you're going to make a lot of something, but just for a one-off, I'd rather just pick and place the parts with my little pick and place pen by hand, lay out the circuit based on a drawing I do on my computer of how I want the circuit to be lined up, and then I just use some silver glue and my dispenser to squeeze out the glue and join all the parts, and then the circuit's done. My work's over. I don't have to use any software, no G-code generation, no CNC stuff, no calibrating a 3D printer and setting it up. None of that. Just do it all by hand instantly. It's almost like using breadboard and jumper wires, except it's permanent, it's rock solid, it's all micro scale, and you can create multi-layer boards this way, and it's professional, and it's ready to go into a robot. You can't just stick a breadboard into a robot. I mean, you could, but that would take up a lot of space. This can be very tiny scale stuff, including cell phone level scale. So this is a very powerful solution for being able to make by hand under magnification perfect soldered, or non-soldered, I should say, perfect PCBs. It's not even printed circuit boards. Perfect circuit boards by hand. It's going to be amazing. So everything I have to do has been added to my to-do list. All the stuff I needed to buy to make these various things come to life, I've purchased. All the research is done. I'll research maybe some little odds and ends as I get to that, but all the actual jobs have been added to my to-do list, and I'm looking forward to actually doing this, and it's going to be my next project for Electronics Day. It's kind of an interruption on the power supply making. I'm going to be doing this and then come back to the power supply making after the fact. So anyways, guys, it was a very productive day. We put in 14 hours. We learned a lot, and we're ready to put it into practice. Everything I learned is going to be put to use. So have a good day or night, guys.